temperature probe has got a time constant about 5 to 5.5 minutes, and then the sensor for the humidity is about 6 to 7. I just replaced the batteries in this Rite weather station, so I measured the time constant of the sensors for the temperature and the relative humidity sensor. Okay, outside this morning it was 35F86 according to the Rite sensor, but it was exactly the same as yesterday. So what happened is the battery failed, and so the remote unit just basically displays the same signal. I measured the time constant on a exterior Rite weather sensor that has temperature and humidity. What I did is I had to change the batteries on it, so it was fairly warm out inside, and then I brought it outside and plotted the temperature and humidity versus time. So zero time here is at 8:50 a.m. and after 30 minutes it's 9:20. Measured the temperature and the humidity. So the unit was at room temperature inside because it was in for several hours because I had the batteries out of it. Put new batteries in, then immediately put it out in the yard, and so the humidity went up like this. This graph, 60, 70, 80, 90, 100% RH, and this left side of the graph has got temperature. Here's 20, 30, 40, 50, 60. So it started at 60, went 50, went down like this. So the final values were 43 outside, 99% RH. So this is 43 RH, 43 degrees, and then 99 RH. So from these curves I can take the total delta and then take 63%, which is one time constant, and you figured out with the temperature probe has got a time constant about 5 to 5.5 minutes, and then the sensor for the humidity is about 6 to 7. So what you have with the first order system, it goes linear up here like this, and then it tends to taper off, and then it goes to the final value. Down over here I've got some little calculations here. Total delta T was 17 degrees F. Total RH difference was 35%. And then you got 1 minus e to the minus 1 is there's a 63%, 86.5, and 95. So you take these numbers times the delta, which was 17F or 35 RH, and you get these values, which is about, first time constant is 11 degrees, 11, 14, and 16 degrees. So you go back here to the graph and you measure 11 degrees from here, and you get down to right there, and there's the first time constant. Second time constant is about 10 minutes here. Third time constant is very close to 15. In actuality, what you have is you have a couple time constants that combine, because the sensor is probably fairly quick, and then the body of the plastic unit probably lags behind because it's thicker. So you can get to where this is basically the most of the sensor, and then back over here you can have it to where it's going to take a lot longer to get to the final point because you've got heat giving off from the surroundings of the sensor. But for practical purposes, this is a fairly good first order system. And that's an inaccurate outside weather station that's got temperature, humidity, and airspeed. Once I replaced the sensor batteries outside, in order to get it to find this, I had to go through and I pulled the batteries out of the back of the unit and reset the time, date, and everything, and then it instantly found the sensor. Some of these units, they don't, if you just replace the outside units batteries, they don't necessarily find each other. This has got a setting so it's got channel A, B, 3 different channels, A, B, and C. It's set to B. But some of the ones I've had over the years, they'll find each other. Other times it's best practice to go ahead and replace the sensor batteries and then go through and put new batteries, or just pull these out, put them back in again, and go through the whole set procedure of the time, date, time zone, year, and all that stuff. Then boom, it instantly finds the sensor. This has got temperature, humidity, and wind, and I believe you can set it for degrees F or centigrade. Now when the batteries die, it says seconds right here. This will be like 99 plus, it never changes.